All right, for the multiple choice section, I just have just a couple of multiple choice problems. We do have 5 of them on our test. This one says, consider the curve given by the parametric equations x and y. The curve is concave upward for the value of t such that. So concave up, we need the second derivative for concave up. And this is that long second derivative formula. So remember, you can say dy dx. That's just y prime over x prime. So that's 3t squared minus 3 over 2t minus 1. But then the second derivative is the derivative with respect to t of dy dx. And then you have to divide it by dx dt. So this is quotient rule here. Low d high minus high d low over low divided by dx dt, which was just 2t minus 1. So if you're dividing by 2t minus 1, that's the same as saying times 1 over 2t minus 1. So you can lump those together, make it 2t minus 1 cubed. I'm going to bring this down here. So, and this is, let's see, this is 12t squared minus 6t. Take a negative 2 through here. Minus 6t squared plus 6. So I have 6t squared minus 6t plus 6 over 2t minus 1 to the third. To figure out concavity, you need to set the second derivative equal to 0 or equal to undefined. I'm going to factor a 6 out of this first. I don't think I'm going to get any answers out of this, but whoops, I don't need the second part yet. If I'm trying to figure out when that's equal to 0, I can use a little quadratic formula. So 1 plus or minus square root of b squared minus 4 times a times c. This is imaginary, so we don't get any possible inflection points from the top. So it's just the bottom, so 1/2. So far I'm thinking it could be c. Here, t equals 1/2 is when this is undefined. So now I just need to plug in 0 and plug in like 1 and see which one gives me positive, concave up. So if I plug 0 into the second derivative, I get 6 over negative 1 to the third. So I get a negative. If I plug 1, I get 6 minus 6 plus 6 over 2 minus 1 cubed. So that's positive. So yeah, concave up is anything after 1/2. Okay, which of the following expressions gives the total area enclosed by the polar curve r equals sine squared shown in the figure above? So take a look at your options before you start setting this up. All of the bounds are from 0 to pi. So the first thing we should do is figure out, where does 0 to pi get you on this graph? So make a little chart. When you plug in 0, sine of 0 is 0. So you're starting here. And when you plug in pi, sine of pi is 0. So you're getting back to here. Now the question is which, I guess it doesn't matter which loop you're on. But remember, these curve in like a counterclockwise fashion. If you plug in pi over 2, you're at 1. So yeah, okay, so this is 0. This is pi. So 0 to pi gets you the top half, and these are symmetric. So we need to double the top half area, which is 1/2 integral from 0 to pi of r squared d theta. So the 2 and the 1/2 are going to cancel, so that knocks out a and d. And then what is r squared? You're doing sine squared squared. So that should be sine to the 4th. Oh, that knocks out the 2 here as well. Yeah, so the difference between b and d, because all the others had coefficients in front, is that it should be the sine to the fourth. And our last two. Okay, find the values of theta at which there are horizontal tangent lines on this graph. So horizontal tangent lines are when dy dx equals 0, and we need a dy dx equation. We're assuming this is non-calculator. So remember, this is where you would need the formula for dy dx. It's equal to r prime sine theta plus r cosine theta over r prime cosine theta minus r sine theta. R prime, the derivative of r is positive sine. Okay, so this is, actually, I'm going to go down below here. So sine times sine is sine squared plus cosine times 1 minus cosine. So that's cosine theta minus cosine squared theta over r prime, sine times cosine, minus r times sine theta. So minus sine theta plus sine theta cosine theta. Now we're only looking at horizontal tangents, so we're looking at when the top is equal to 0, but we do need to double check that whatever answers we get, if we plug them into the bottom, we can't also get 0 in the bottom. So I'm just going to clean this up a bit. I have 2 sine theta cosine thetas and then minus sine theta. All right, so horizontal tangent. So we're setting the top equal to 0. Now, if you're setting sine squared plus cosine minus cosine squared theta equal to 0, you can't factor this unless they're all in terms of sine or cosine. And because the linear term is just cosine, you've got to trade out the sine squared for 1 minus cosine squared. Now we have this all in the same trig function, so it's like 1 plus cosine theta minus 2 cosine squared theta. You can factor a negative out of that if you want, or you can just start factoring it. It's got to be 2 cosine and cosine. We're trying to get positive cosine, so it's got to be plus 2 minus 1. And this means that cosine theta could equal negative 1/2, or cosine theta could equal 1. In the first scenario, theta equals, so they're pi over 3 angles, and we're in quadrant 2 and 3. And then this one is theta is 1 when theta is 0, or cosine is 1 when theta is 0. Now, again, we need to double check these to see if we throw any of them out. It's usually the non-quadrant angles that mess things up. So let's check 0 first. So if I plug 0 into the bottom of dy dx, I just want to make sure that I'm not getting 0 over 0. So 2 times sine of 0 times cosine of 0 minus sine of 0, which is 0. So I have to throw 0 out. The 2 pi over 3 and the 4 pi over 3, I think they're going to be fine. 2 times 1/2 times, times radical 3 over 2 times negative 1/2 minus radical 3 over 2. There's not going to be any issue there. That's negative radical 3 over 2 minus radical 3 over 2, so that's okay. That's not 0. And 4 pi over 3 should be 2 times negative radical 3 over 2 times negative 1/2 minus negative radical 3 over 2. So this is going to work out to be radical 3 over 2 plus radical 3 over 2. So that's okay as well. So these are the two, find the values of theta. So these are the two values of theta. Okay, and our last one, I'm going to be honest, I used to have a question like this on the non-calculator, but after talking with a few people that have graded the AP tests, they don't require us to do this one without the calculator. So I will keep my long non-calculator work on there, but I just want you to be able to graph this and set up the area equation. But you're not going to have a long 1 plus sign, like having to use that half angle formula and whatever. So we need to graph this just to see what the bounds are. We want the area inside the thing. So plug in 0, you get 1 plus 0. So it starts here. Plug in pi over 2, you get 1 plus 1 is 2. Comes up here. That's 0, that's pi over 2. And then pi gets us back to 1. This is one of those cardioids, right? So I need to figure out what brings it back to 0. So let me get 3 pi over 2. That gives me 1 minus 1. So far, it's going to look something like this, and then it'll come back around. So I don't want to start at 0 and go somewhere because 0 does not represent half of this heart. I want to start at pi over 2 and find this area and then just double it. So 2 times the area from pi over 2 to 3 pi over 2 of r squared d theta. I am not going to go through the long, square this out and use your half angle formula and all of that. I will save the work for that on my key that I put on here. But you don't need it for our test. You don't need it for the AP test, so I've been told. So yeah, I'm just going to do it here. And I will check it against the exact answer that I got. But otherwise, we're going to save ourselves time and worry and headache about that. All right, when I did this without a calculator, I got 3 pi over 2. Oh, whoa. Typed that in wrong. 3 pi. Oh, no. Okay, I'm blaming this on either my mouse or my computer screen. 3 pi over 2. There we go. This is correct. I do get the same decimal approximation for 3 pi over 2. So 4.712, 3 pi over 2 exact. All right, that finishes up our test review. So again, you don't need to know that cosine squared is equal to 1, plus cosine 2 theta over 2. You're not going to use that for our test or for the AP test.